In this video, we'll graph the function f of x equals negative 2x squared plus 4x plus 8 by finding the vertex, x-intercepts, and y-intercept. Then we'll review the domain, range, max-min values, and the axis of symmetry. Because this quadratic function is in the general form, we will use the vertex formula to find the vertex. Recall that x is equal to negative b over 2a, gives us the x value of the vertex. In this case, we have the opposite of 4 divided by 2 times the value of a, which is negative 2. So negative 4 divided by negative 4 is 1. The y value of the vertex is obtained by replacing x with 1 in the function to get negative 2 times 1 squared plus 4 times 1 plus 8. Using order of operations to simplify, we get negative 2 plus 4 plus 8, or 10. So the vertex is the ordered pair of 1, 10. The x-intercepts are obtained by setting y equal to 0 and solving for x. So we solve the equation negative 2x squared plus 4x plus 8 is equal to 0. We have a common factor of negative 2. If we divide through by that, our equation is just a little bit easier to solve. That gives us x squared minus 2x minus 4 is equal to 0. To solve a quadratic equation, we can try factoring, but factoring does not work in this case. So we would have to use either the quadratic formula or completing the square. I'm going to use completing the square since we have a 1 on the squared term and an even coefficient of x. To complete the square, we would add 4 to each side to get x squared minus 2x equals 4. The number that completes this square is half of negative 2 squared. Half of negative 2 is negative 1, squared is 1. And then we add that number to each side of the equation. Adding 1 created a perfect square trinomial on the left. X squared minus 2x plus 1 factors as x minus 1 times x minus 1, or x minus 1 squared, equals 5. Now we apply the square root property to get x minus 1 equals plus or minus the square root of 5, or x equals 1 plus or minus the square root of 5. So x is equal to 1 plus the square root of 5, which is approximately 3.2, or x is equal to 1 minus the square root of 5, which is approximately negative 1.2. So our x-intercepts are 3.20 and negative 1.20. The y-intercept is obtained by replacing x with 0, so f of 0 is negative 2 times 0 squared plus 4 times 0 plus 8, which is just simply 8. So that y-intercept is 0, 8. So plotting all of these points gives us the graph. We can plot 110, 0, 8, 3.20, and negative 1.20. Now notice that the parabola opens downward, which we would know that because the value of a is negative, which tells us that the graph opens in a downward direction. The domain of a quadratic function is negative infinity to infinity. There are no restrictions on what x can be, and the graph extends infinitely from the left to the right. The range we read from bottom up. So notice that the graph is extending downward, but it has a topmost point at 110. And the y value of that vertex is our maximum point, which our range then is negative infinity to 10 with a bracket. So the maximum value is 10. The maximum is always the y value of the highest point. There is no minimum value because the graph goes infinitely downward. The axis of symmetry is a vertical line that runs through the vertex, so that would be the vertical line x equals 1.